Everyone, you're welcome to the 8th session of Business Mathematics. In today's session, we are going to explore one of the most important concepts in the time value of money. Right? At the end of this session, we should be able to get the concept of simple and compound interest, the time value of money and compound interest, the relationship between present and future cash values, single amounts, streams of cash flow, where we have the types of cash flow, a uniform cash flow, arithmetic gradient cash flow, geometric gradient cash flow, and cash flows in perpetuity. Right. On our next slide, we have what is called cash flow. Cash flow refers to the inflow and outflow of money over a period of time. This money that we are receiving are called inflows. The money leaving the business is called outflow. So when we receive money, we make sales. It's an inflow. When we make purchases for raw materials or purchase of raw materials, we buy it with money, right? So that's an outflow, money leaving the business. These inflows and outflows are represented on a cash flow diagram or a cash flow table. So there are two tools used to represent cash flow. That's cash inflow and cash outflow. The first one is the cash flow diagram. It's just the normal line that we know in our basic school, right? But here it is called a cash flow diagram or the timeline of money. So we have period 0 here, period 1 all the way to period n. Period 0 here has to do with the present value. Period 0 here is the present value, or period 0 here represents today. In layman's term, it is today. So it's a present value. Apart from period 0, any other period here is in the future. So from year 1 to year n over here, they are all future values. They are all in the future. But period 0 is what we call present value or today. Right. Year 0 here, which is today, is the beginning of year 1. At the beginning of period 1. Year 1 itself is the end of year 1, but the beginning of year 2. I'll take it again. Period 0 is the beginning of period 1. Year 1 is the end of 1 here is the end of year 1. Again, this year 1 here is the beginning of year 2. 2 itself is the end of year 2. Again, year 2 is the beginning of year 3. 3 itself is the end of year 3. That is how it's been interpreted, how we interpret the cash flow there. Note that the arrows here that is pointing up, and then the ones it could be showing that, could be showing up, that's the arrow. The arrow is representing the inflow and the outflow. So if the arrow is pointing up like this, it means that you're representing a cash inflow. But if the arrow is showing down like this, it means that you are representing a cash outflow. The height of the arrow is dependent on the amount of cash, right? So the height representing amount of cash. So if it is basically, if you have 500 million inflow, right, it will be, the arrow will be a bit higher than 400 million inflow. That's what I'm trying to say. So if you have 500 million, it is a bit higher than that of 400 million, right? The second tool that is used to represent a cash flow is what we call a cash flow table, right? A cash flow table. So a cash flow table lists the period and the corresponding cash in a table. However, unlike a cash flow diagram, it doesn't show whether cash is received at the beginning or at the end of a period, right? This cash flow diagram doesn't really show, it doesn't show if the inflow or outflow is being received at the beginning of a period or the end of a period, right? But this cash flow table does. So example is that depicts the following cash flows of a company on a cash flow diagram. So we are showing this cash flow tables here, representing this cash flow tables here on a cash flow diagram, right? So we have from year 1 to year 7 over here. You see some of these are the inflows and the outflows. The negative ones here that are seen represents cash outflow. The positive values here represents cash inflows. So represent this cash flow table on the cash flow diagram A when money is paid out or received at the beginning of the year, and when money is paid out or received at the end of the year on a cash flow diagram. Right. So this is how we represent it on the cash flow diagram, taking note of this number of years and then the inflows and outflows. So this is when money is paid out or received at the beginning of the period or the year. So year one, we said beginning of year one, that's what it's trying to say, represents this minus 100 million or negative 100 million, which is a cash outflow at the beginning of the year. So beginning of year one is 0. It's an outflow, so it goes down like this. The arrow shows down, representing an outflow or a cash outflow. Year two is also telling you that represent this amount of minus 10 million at the beginning of year two. Remember, the beginning of year two is year one. Beginning of year one is 0. End of year one is 0. Beginning of year two is 1. End of year two is the 2 itself. So the beginning of year two is 1. I represent minus 10 million here, down showing an outflow. Third year, beginning of year 3 is year 2. Inflow 10 million, it goes up like this, showing an inflow. Year 4, beginning of year 4 is the third year, showing a 15 million inflow. Beginning of year 5 is year 4, showing an inflow of 40 million. Beginning of year 6 is year 5, right, showing another 40 million. You see, this is the same because they are all 40 million inflow. Beginning of year 7 is year 6, right, that is showing another 50 million inflow. You can see that at the end there's nothing on the 7th year because these cash inflows and outflows are being represented at the beginning of each of the periods. So beginning of year 1, beginning of year 2, beginning of year 3, beginning of year 4, year 5, 6, and year 7, right? So how do we represent this at the end of the year, right? We're being represented at the end of, at the end of the year, right? So end of year 1, end of year 2, all the way to end of year 7. Year 1 is the end of year 1, 2 is the end of year 2. So end of year 1 is year 1, showing an outflow of 100 million. Year 2, outflow of minus 10 million at the end of year 2, which is year 2 itself. End of year 3 is 3 itself, showing a positive value, right? That's 10 million, which is an inflow, so it is going up. End of year 4 is the 4th year, showing an inflow of 50 million. End of year 5 is the 5th year, showing an inflow of 40 million. Same for year 6, same for year 7. This cash flow diagram here depicts how money is represented. That's an inflow and outflow at the end of a year or at the end of the period, right? So at the end of year 1, end of year 2, end of year 3, 2 out to the end of year 7, right? We're looking at what is called interest rates. Interest rates, right? Where you have the simple interest and a compound interest. Okay. So suppose the principal, that is P, is the current amount of money and I is the interest rate, and over a time period, N is the number of years. If Pn is the amount of money attained at period N, then the interest rate at period N is the amount of money attained at period N minus the initial amount. Right. The business world, however, prefers the use of interest rate, which is the percentage of interest earned over a principal than the interest. So we say that I is our interest, and then we can find our I being the interest over the initial amount times 100%. So interest rate is the initial amount that you have times the interest. That will give you the interest on that amount. That is what I'm trying to say. So we have two types of interest. You have the simple interest for a very short life project and usually smaller than interest rates. And we have a compounding period, that's the compounded interest, right? So let's delve into how this interest are being used or what they usually mean. So that's the present amount into bracket 1 plus the interest. 1 here is a constant, P is the present amount or the principal, right? Gives you the total amount as the principal plus interest after 1 year. So you have a certain amount and then you calculate interest on it. To get the total amount, it is the amount that you have plus the interest that will give you the total amount after a year. So say 1 year period. So the principal here, right, that's the initial amount of money invested or borrowed. That is the P. I here is the interest rate per period. 1 plus I, that's the constant plus the interest rate, is the growth factor after 1 year period. So this table shows how the calculations for simple interest and compound interest are being done. So we have the year beginning amount, the interest, the ending amount. That is for the simple interest. So for the simple interest, if you have an amount, right, at the beginning, you're not going to receive any interest on it. That is the same day that you have the money, right? Say you are making or you borrow an amount of money from a financial institution. If you borrow from them, that is today, 0. You're not going to pay interest on that amount, isn't it? So the beginning amount is the principal that you have, but there's no interest on it because that is the same present amount that you have. You went for the amount presently, so you're not going to pay any interest at that moment. It is when it has gone over a year or there's 1 year period on that amount. That is when you start paying interest. So the beginning amount is P, that is the principal, no interest, and the ending amount is equal to the principal. So ending for beginning of year 1 becomes the closing balance becomes the opening for year 1. So ending amount becomes the opening for year 1, and then year 1 it has elapsed a year, so you start paying interest. So to get the total amount, it is the principal amount, which is the beginning amount, and then the interest is the principal amount times the interest, and that should give you the ending amount, which is the total amount, and that is the principal amount you have plus the interest that you calculated. That is the P plus PI. For year 2 will be the same. So ending amount here becomes beginning for the second year. That will be this. The interest will be the same principal times the interest. And then the ending amount is the principal that you have plus this. That is 2PI. Right? So that is how it goes. And then we have that of the compound interest. It is compounded. So that one, it is the beginning amount here, no interest. It becomes the principal, which is the same for the year 1. To get the interest, it is just the principal amount times the interest. And then the ending amount is what? P, that is the principal amount plus the interest. So P plus PI becomes the ending amount. And it's the same as P into bracket 1 plus I because you can factorize this to get this. That's what you're trying to say, right? So that's the difference between the compound interest and then the simple interest. So for simple interest, the total interest is what? The number of years times the principal times the rate, right? So principal times rate times time. That's what I'm trying to say. Okay. So for compound interest, the total interest is the principal into brackets 1 plus I raised to the power n minus P. P is the present value, I is the interest rate, N is the future value. Sorry, N is the number of years, right? The number of years. Then to get the total amount, it is at period N, it is the principal into bracket 1 plus I raised to the power N for compound. Right. So that's compound interest is the interest N, not on only the original principal, but also on all interest N, right? Period N. previously. In other words, at the end of each period, the interest earned is added to the original amount, which is the principal and the money reinvested. So the formula F into bracket, so F is equal to P bracket open 1 plus R raised to the power N is at the heart of many calculation in finance. This formula here is just telling you that to find the future value of a single sum, right? So if someone promised you 10,000 Ghana cedis, let's say today, right, to give you 10,000 Ghana cedis today at a given rate, say for 2 years, right? And I'll say that no, I don't need the 10,000 Ghana cedis now. So I'll take the 10,000 Ghana cedis rather in the 2 years' time. So at a future date. 10,000 Ghana cedis today is not the same in 2 years' time at that given rate. So if you want to find how much the 10,000 cedis will be worth at that future date, which is a single sum, the future value is equal to the present value 1 plus that interest raised to the power the number of years. That will give you how much the 10,000 will be worth in 2 years' time, right? So this is the future value of a single sum formula, right? So we're looking at the time value of money. The time value of money represents the purchasing power of money at a given point in time. A cedi today is not worth the same tomorrow. So if you're able to purchase something worth 15 Ghana cedis today, you can buy it with the same 15 Ghana cedis in 2 years' time. So if you bought a smartphone, right, or you bought an iWatch for 1,000 Ghana cedis, you can't say that you are going to purchase it 10 dollars, you're going to buy 1,000 Ghana cedis or the same amount in 5 years' time or in 10 years' time. No, because of what is called the time value of money, right? It could be that the amount will depreciate or it will go up, right? Depending on what is going on, the inflation rate or the deflation rate. The amount that you used to buy the iWatch, it can decrease or it can increase. So that's what it's trying to tell you. Like, for instance, today you can buy screen protector for 25 cedis. You may not buy the same screen protector for 25 cedis next year, right? So a cedi today is not worth the same tomorrow. It could be 20 cedis next year, or it could be 30 cedis the next year, or even 40 cedis. Another example is that if a friend borrows 200 cedis from you today, right, it is fair for her to return the 200 cedis to you next year without any compensation just because she's a friend. There are 3 economic factors that influence the time value of money. So if I borrow a friend borrows me 200 cedis today, and then she decides that, oh, you can bring the money back next year, paying the same fee. That means the person is not charging me any interest rate. But if there's an interest rate on it, right, taking other factors into consideration, so you can tell me that 200 cedis, if I'm borrowing it today, and I'm paying in 3 years' time, she's charging a rate of 3% on it. That means I'll pay more than that in 3 years' time, right? So she's charging 0.03. So if I want to find how much I'll be owing her in 3 years' time, it is 200 cedis into brackets, or 200 into brackets, 1 plus the interest rate 0.03, bracket close, raised to the power 3. And I'll be owing her 218 cedis, 0.54 pesos, or let's say 55 pesos. That means if you owe someone 200 cedis today, you're not going to pay the same amount tomorrow. That is what it is trying to tell you. So it is a time value of money. So some of the factors are opportunity cost. You miss the chance to earn money from 200 cedis during the year. In other words, you could have earned interest if you had started some business or deposited the money into a savings account. Another factor is depreciation. An equipment machine loses its efficiency, right? Its efficiency over time, and is likely to be less productive as time goes on. That is depreciation. So if you bought a machinery for production, $20,000, if it depreciates due to factors like wear and tear, obsolescence, fusion of time, and the rest, you can't say that you are going to sell that machine for 20,000 Ghana cedis. Whilst it has depreciated in value, it's unable to work like before. You sell it less than that, right? So another factor is also inflation. The cost of product increases every year, right? Hence, money devalues. So if you are buying a protector for 25 cedis. Next year, you can buy it for 40 cedis, right? Or if it's decreasing every year, you can buy it for 15 cedis or 10 cedis. So considering all these three factors, it will not be fair for the neighbor to return the machine next year or the 200 cedis next year without any compensation, right? This cost focus solely on the first factor, opportunity cost, and primarily addresses scenarios involving an individual or entity in the bank. So we'll delve into this and we'll get more understanding on it. So the relationship between present and future value of a single sum of money, right? Of a single sum. So we'll see the relationship between present value and future value of a single sum. So P and F here represents the current time period, where P is the present value, F is the future value. That is time period N is the number of years given, value of a single amount, assuming an interest rate which is constant, will remain at I within the period considered. Then the present amount and the future value are related by the formula. The future value of a single sum is equal to P into bracket 1 plus I raised to the power N. F is the future value, P is the present value, 1 is a constant, I here is the interest rate, N is the number of years. Note that this formula is a single sum, is for a single sum, and N is the number of periods from the future period to whatever present time in mind. So that's what is here, future value of a single sum formula. Right? Like I just explained earlier. Usually the present is time 0, that is period 0 on the cash flow diagram. However, there will be instances where, for purposes of calculation and the sake of the time period and the present, we could later consider the future value to be taken to time 0, right? So it's just telling you that a future value that you have can be brought to period 0. That means you can find the present value. This is just telling you that you can also find the present value of a future sum. So if you have someone is promising you that, oh, I'll give you an amount of money, let's say in 2030, you say that, right, I need the money to, let's say, buy something now or purchase some books for myself or course materials. So I want the money that you are promising me at a future date today. That means you want to find the present value of a future amount. So that is also the present value of a future amount or present value of a single sum. Right. So let's take this example here. We have a cash flow diagram here. Period 0 here, that's the present. Period 1, inflow 2,000, period 2, inflow 3,000. Find the present value of the cash flow shown above when interest rate is equal to 5%. So remember that year 0 is the present value, or today, year 1, year 2 going in the future. So if you have values here, this cash flow diagram is just telling you that bring these two values, which is 2,000 and 3,000, back to year 0, or find the present value of these future amounts. Right. So we know that the future value is equal to P into bracket 1 plus I raised to the power N, but we want the present value here, which is period 0. So we'll just make P the subject, and I'm going to get the present value of a single sum formula. F, which is the future value, over 1 plus I raised to the power N. Right. For the future amount of 3,000 at period 0, it has to move back 2 times. It has to move back 2 time periods to the present value 0, or the period 0. That's what it's telling you. So I can do it like this. So you can start with this, or you can start with this. How many times you have to move from period 0? Remember, you're finding the present value. How many times you have to move from period 0 to move from period 2 to period 0. Remember, these two values here are in the future. We are bringing them to the present value, or we are finding the present value, like what the question is saying. So starting with period 2, let's start with period 2. How many steps from period 2 to period 0? Right. I can just look at this and say that we have 2 here. 2 here represents n, which is the number of years. So n is 2 in this formula. Or how many steps from year 2 to period 0? I'll move 1, 2. So n is 2. So you don't count it 1, 2, 3. You move 1, 2 steps to get to present value of period 0. So n is 2. So we see that period 0, or the present value of the 3000, is 3000 over 1 plus the raised, which is 0.05, raised to the power 2. N is 2 here. Or we move how many times to period 0? 1, 2. Okay, so we have the future amount, right? And then we can find that of the 2000 as well. So however, for the future amount of 2000 at period 1, here, n is 1. Looking at here, you have n is 1. Or how many times you have to move, or what are the steps to get to period 0? It's just one step, right? Unlike this one, you move twice, right? So we have 2000 over 1 plus the interest raised to the power n, and that will also give you the present value of the 2000, right? So the total present value of the cash flow above is just finding the present value of the 3000, find the present value of the 2000 here, you add them, you see, and then you have the total present amount to be 4625.85. So what does it mean? It means that if you have an amount of 2000 in year 1 and you have an amount of 3000 in year 2, at a given rate of 5%, the present value of this future amount is this 4725.85. So you are indifferent between receiving this amount today and receiving 2000 in year 1 and 3000 in year 2 if the interest rate were to remain 5% per year. So if you decide not to take 2000 in year 1 and receive 3000 in year 2, then if you want the amount presently, this is what that two values over here are worth in today's term, right? Let's look at a practical example. Find the present value of the cash flow shown below if interest rate I is 10% per year. And so here you have the years, you have the what? The inflows and outflows. So this is how to represent it on a cash flow diagram. Remember that this, you don't have any period 0 here, so it's represented at the end of each of the years, right? End of year 1, 2000, end of year 2, 5000, end of year 3, 0, end of year 4 is an outflow of 2000, end of year 5 is an inflow of 3000. So you have to find the present value of all these future amounts from year 1 to year 5 are in the future. We are bringing all of these values to period 0. So the first one will be 2000 over 1 plus the interest 0.1 raised to the power 1 because it's the first year. Or how many steps to year 0? 1. Second year will be 1, 2. The third year will be 1, 2, 3. Same thing. Or you can just look at the values over here. So you do everything here. Remember, this is an outflow, so it is minus 2000 over 1 plus 10% raised to the power 4. And then the last one. The summation of these values here will give you the present value total of 6447.15. Right. Here we have the types of cash flow. The first one is the uniform cash flow. Uniform cash flow here refers to the amount of cash inflow and outflow received in the same. Okay. So for uniform cash flow, the amount of cash inflow and outflow is the same each time period. Right? It means that for uniform cash flow, you are receiving the same amount each year. The inflow and outflow are the same. So if you are a worker or you are an employee at an accounting firm and you are being paid a salary of 2,000, a fixed salary of 2,000. That means you are receiving 2,000 every month, or let's say every year, based on the payment structure, right? So this is how represented. You can see if it's an inflow, it is the same. The arrow is an inflow showing this. Is it the same height? The A here represents that the amount you are receiving is the same. It is fixed. So we call that fixed amount you are receiving throughout a number of years annuity or equal amount. So A is called annuity or equal amount. Right. So you are receiving the same amount throughout. It's fixed. So it is called annuity. This A means annuity or equal payment. So these values here are all in the future, right? So if you are being asked to find the present value or the present sum of these future values, because they are fixed, you use the formula called the present value of a uniform cash flow, right? Of a uniform cash flow. And this is how the formula looks like. So this steps is showing you how the present value of a uniform cash flow was being done or how it was found. So you go through this series of steps to arrive at this final formula here, which is saying that P is equal to A over I. So present value of a uniform cash flow is equal to that equal amount you are receiving or the annuity over the interest. 1 plus the interest raised to the power of the number of years minus 1 over 1 plus the interest raised to the power n. That this formula is the present value of a uniform cash flow formula. Right, take note of that. Right. So the present value of a continuous uniform cash flow that begins at the end of period 1 and period 1 to end of period n is as shown in the equation. So it is this, right? So in general, the equation that we had earlier has to do with what? Finding the future value of a continuous uniform cash flow that begins at any period, not necessarily at period 1. The present value P occurs 1 period before the occurrence of the first uniform value. Also, N in the formula is equal to the number of uniform cash flows or the number of years you are receiving the money. Note also that since F is equal to P into bracket 1 plus I raised to the power n. So we already know the formula for present value of a uniform cash flow. We can also find the future value of a uniform cash flow, and this is how the formula here was also gotten, or we brought about it. So note that F is equal to P bracket open 1 plus I raised to the power n. We can find the future value of a uniform cash flow by simply replacing P with the formula from equation 3, which is saying that P is equal to A over I bracket open 1 plus I raised to the power n minus 1 over 1 plus I raised to the power n. This is the present value of a uniform cash flow. We are looking for future value of a uniform cash flow. So using this formula here of a present value of a single sum represents this P with this formula, which is from equation 3. So it represents that over here. You can see that from this side, the denominator here, 1 plus I raised to the power n will cancel this. So this one will cancel this. And I left it. The future value of a uniform cash flow is equal to A over I multiplying 1 plus I raised to the power n minus 1. And that is the formula for future value of a uniform cash flow. Thus, the present value of a continuous uniform cash flow is this formula, and the future value of all uniform cash flow is also this formula. The future value here, formula here, represents the total amount you will have in the future date when you deposit or receive equal payments, which is the A over here, at regular intervals, right? Assuming payments are earned at what? Are earned at a constant interest rate. That's the I over here. This will just give you the total amount you have in the future when you receive or deposit equal payments, right? And then we'll continue. This is same for that we have the formula here, two formulas here. So how do you apply that? So looking at this formula, we'll take this practical example. In this example, we test the power of shortcuts. Find the net present value or the present value of the cash flow shown below, right? With I being equal to 5%, as the interest rate being equal to 5%. So we have the cash flow diagram here. Remember, this is period 0, right? So from period 1 to period 6 is a future value. So you say we should bring all these values here to period 0, right? So because this amount is a uniform amount, you are receiving 5,000, 5,000 throughout the 6 years. So we can use this approach, what we learned earlier, using the present value of a single sum. Find that of period 1, where n is 1. Add that of period 2, we move 2 times to get to period 0, n is 2 here. We'll do it for all the 6 years. This is called the brute force approach. Finding it one after the other. Then we'll sum them. And that will give us 25,378.46 as our present value or the net present value of that uniform amount. We can also use the shortcut or the formula we just learned for present value of a uniform cash flow, right? It says that it is your annuity or that equal amount, which is 5,000 every year. So the A represents the 5,000 you're having here. So 5,000 over the interest rate. Then we have this 1 plus the interest raised to the power. How many years do you have to move from year 6 to year 0? It is you are taking it for 6 years. So basically n is 6. Or how many steps do you have to move from year 6 back to year 0 here? Because year 0 is a present value. So it is 1, 2, 3, 4, 5, 6. You move 6 times. That's why n is 6 here. Or when you count it is 1, 2, 3, 4, 5 for 6 years. 6 years. So you have the same answer. So whether you go by the brute force approach or the shortcut, you get the same one. But you see, if you use this approach when the amount is uniform, it is going to be a bit tedious. So you just use a shortcut for present value of a uniform cash flow where the formula is more convenient. That is what it's trying to interpret. Right. So let's continue using the formula that we've learned to answer this question. It says that the government of Ghana is to receive an amount of 10,000 for the next 100 years. So 10,000 every year throughout the 100 years. If interest rate is assumed to remain at 2% per year throughout the 100 years, find the net present value of all the cash flows. We know that the annuity or the A is 10,000 because 10,000 throughout the 100 years. So it becomes an equal payment or is an amount that I receive every year for 100 years. So n number of years is 100, the interest rate is 2, and then the annuity is 10,000. You put it in the present value of a uniform cash flow formula that we learned earlier, you will get 430,983.52. So if you are receiving 10,000 Ghana cedis for 100 years at this interest rate, this is how much the money will be worth in today's term. That's what it's trying to say. So presently, this amount for 100 years is 430,983.58. Another example here, right? So we have the cash flow diagram here. We have nothing here for, this is present value, nothing for year 1. There's nothing here for year 2. Period 3, you are receiving an inflow, 5,000, 5,000, 5,000. It becomes a uniform amount, right? It becomes a uniform amount. But you should take note of this caveat, which is saying that, take note of this caveat, which is saying that, using the present value of a uniform cash flow formula, which is here, it brings you to the period immediately preceding the beginning of the cash flow. In simple terms, this you are receiving this amount for 3 years, right? Bringing this back to year 0 it's not going to bring you automatically to year zero. That's what it's trying to say. It brings you to the period immediately preceding the beginning of this cash flow. It means that we are receiving this for 3 years, right? 1, 2, 3. So it's going to bring us to 1, 2, 3. It will bring you to year 2 instead. That's what the caveat is trying to say. It brings you to the period immediately preceding the beginning of the cash flow. Right. So you take note of this. That is 5,000 that you're receiving. That's the annuity over the rate 1 plus the rate raised to the power 3. We know it is 3 years. So 1, 2, 3. But it brings us here, not to year 0 directly. Minus 1 over this. That will give you 13,716.20. It will bring you to year 2, but not year 0. The caveat is that using this formula brings you to the period immediately preceding the beginning of the, and the period immediately preceding the beginning of this cash flow 5,000 is year 2 or period 2. So it brings us to period 2. And that is the value here. The next thing is that we want to find the present value. Year 2 is still in the future. So this amount is still in the future, which is the year 2. What do? You carry this amount as a single sum to bring it back to year 0. So it is bringing us here, which is 13,000 and what? 16.20. We'll bring that value back to year 0. So how many times do we move? 1, 2. And that means n is 2 years, right? So use the formula for present value of a single sum, which is saying that is the future value over 1 plus I raised to the power n, and that will give you the net present value to be 12,350.33. Right. So another example, you borrowed 10,000 from EcoBank at an interest rate of 10% to be repaid in 5 years. What is the equal amount to be saved each year in order to repay the loan in full at the end of 5 years? You borrow this amount, right? 10,000 at this rate for 5 years to be repaid in 5 years. What is the equal amount to be saved? That is just telling you that find the annuity, right? Find the equal payment, which is the A. So what do? It means that the present value of a uniform cash flow formula, we are going to make A the subject of this relation over here. And making A the subject, going through the steps, we are going to get this formula as the annuity or the A formula. That's the equal amount formula, which is saying that it is the present value times the interest, 1 plus the interest raised to the power n over 1 plus I raised to the power n minus 1. And that is what we have here. And that will give you an amount of, or equal amount of 2,737.97. It means that for the person who borrowed this amount from EcoBank to be able to repay the 10,000 in 5 years, the person should be saving 2,737 every year. So at the end of the 5 years, the person will accumulate the 10,000 to pay EcoBank. Right. Another practical example here, find the net present value of the cash flow below, assume interest rate to be 5%. Looking at this cash flow diagram, you have an inflow which is uniform for year 1, 2, 3, 2,000 throughout the 3 years. Year 4 here, you have a single sum of 7,000. From year 5 to year 8, you also have a uniform cash flow of 4,000 throughout 1, 2, 3, 4 years, right? So you have to find the present value. This is a uniform amount, so you can say that we can bring this here directly to year 0, right? It will bring you to the period immediately preceding the beginning of the cash flow, which is year 0. So automatically, this 2,000 for 3 years brings us to year 0, right? So from period 0 from 8. So this is period 0 from 3, sorry. So 1, 2, 3 will bring us to year 0. So n is 3. Using the formula for present value of the uniform cash flow. So 2,000 over this, 1 plus the interest raised to the power 3, the number of years is 3, or we move 1, 2, 3. That will give you 5,446.5. Right. We are done with the first part. But you can see that we have another uniform amount here. Right. We have another uniform amount here, which is what? 4,000, 4,000, 4,000, 4. 1, 2, 3, 4 years. But it's not going to bring you to year zero directly. It will bring you to the period immediately preceding the beginning of the cash flow 4,000, which is what? Period 7, or sorry, period 4. So 1, 2, 3, 4, it is n is equal to 4 years, will bring us to year 4, not year 0. So P4, right, from 8, that is 1, 2, 3, 4. Uniform amount of 10,000, sorry, 4,000. So 4,000 over the interest into bracket 1 plus the interest raised to the power n, which is 4. We move 4 times to get to period 4, right? Over this, we give you 14,183.8. Remember, this amount here is still at period 4, right? It's not a period 0 value, it's in period 4. It brought us here. So what do? You add the 7,000 to the 14,183.8. Then you have 21,183.3. It means that this value is in period 4. We'll add the single sum to whatever value we have. We carry that total amount of 21,183.8 as a single sum. Then we bring it back to year 0. So here we have a total amount of 21,183.8. To year 0 will give us 1, 2, 3, 4. It means that n is what? N is 4. But they're not going to use this formula again. Now the value or the amount is the single sum. So you use the present value of a single sum formula. That will give you the amount, total amount over 1 plus the interest raised to the power n, which is 4. That will give you this amount, 17,247.96. Then to find the net present value is the summation of the first uniform amount plus that of the single sum that we had. So 5,446.5 plus 17,247.6 will give us a total amount of 22,694.46. That's our net present value. So first of all, deal with the uniform amount. This will bring you directly to year 0. This is also a uniform amount, but it will bring you to year 4 instead. The period immediately preceding the beginning of the cash flow. It will bring you here. Add that amount to this 7,000. Carry it as a single sum. Bring it back to year 0. And then you add the two values to get the total amount or the net present value. The next type of cash flow is called the arithmetic gradient cash flow. This simply means that it's a build-up of the uniform. You are receiving a uniform amount, but that uniform amount is also being increased by a fixed sum. So you are receiving a salary of, let's say, 4,000 Ghana cedis, but that salary is being increased by 200 cedis every year. Every year you get 200 cedis increments. That is the idea of the arithmetic gradient cash flow. So you can see that it's A here increases by K, constant amount, increases by 2K, 3K. So every year increases by 1 each. That's what I'm trying to say. So if you see you are receiving a fixed sum of 4,000, that is increasing by 2,000 every year. 2,000 every year. That's what it's trying to say. So there's a uniform amount there, which is what? 4,000. And it is increasing by what? By K, which is the 200 Ghana cedis, right? So that's what the diagram here is trying to say. So for that one, you need two formulas to find the total present value, because it is a fixed amount that you are receiving, but it's increasing by a fixed sum, right? So we need two formulas. Let PA and PK represent respectively be the present value of the uniform ingredient part. Also, let PT be the total present value of the arithmetic gradient cash flow. So to find the present value total, you need the present value of a uniform cash flow plus the present value of the increment, right? So you find the two, you add them. We already know the present value of a uniform cash flow. So we have to find the formula for the present value of that constant increment. You go through this series of steps. This is not a maths class, so I'll skip this series of steps to get the PK formula. So to find the PK here, this is the formula over here. It says that this is the final formula here for the PK, right? It says that to find the PK, we know the PE already to be present value of a uniform cash flow formula. So total is PA, present value of a uniform cash flow formula, plus or minus the PK. The constant increment can be a positive value, which is an inflow, or it can be a negative value, which is an outflow. It could be that the salary you are receiving is reducing by 200 cedis, or it is increasing by 200 cedis. That is what the plus or minus here is trying to say. So if it is decreasing, you subtract. If it is increasing, you add. So the formula for the PK here is that constant increment over interest rate squared into bracket 1 plus the interest raised to the power n multiplying bracket of 1 plus I raised to the power n minus n times I minus 1, right? Right. So that's the formula for the constant increment, right? I'm sure we will get this going through a practical example. So let's look at this example here where we have um, a cash flow diagram, I would say, right? Arithmetic gradient cash flow is when the amount you are receiving here is a uniform amount, but it's increasing by a gradient or let's say a fixed sum. So it means that this one, it means that you are receiving 3,000 throughout the 10 years, but every year the $3,000 is increasing by 500, 500, 500 every year throughout the 10 years. So find the present worth of a cash flow that begins with what? 3,000 in the first period. So you can be given a preamble like this to represent it on the cash flow diagram before you can even solve. So you should know how to represent uh, problems like this or questions under financial maths on the diagrams, right? So if they tell you that it begins with 3,000 in the first period, that is year one, and increases by 500 per period for 10 years. It means that every year you are receiving 3,000, 3,000, 3,000, but it's increasing by 500 Ghana cedis or $500 every year. So year one is 3,000. Year two will be $3,500. Year three will be $4,000. Year four will be 4,000 throughout the 10 years. So what do? You find the present value of that uniform amount, which is the 3,000 for the 10 years. Then you find the present value of that constant increment 500 throughout the 10 years. Then you sum them. That's what I'm trying to say here under the arithmetic gradient cash flow. So the annuity is what? 3,000. The K, which is the constant increments every year, is 500. Interest rate is 5. How many years are you receiving this? 10 years. So first of all, we find the present value of that uniform amount. So A, which is 3,000 over the interest, 1 plus the interest raised to the power 10 years, n minus 1 over 1 plus the interest rate raised to the power 10, right? That will give us 23,165.20 as the present value of that uniform amount, 3,000. Then we'll find the present value of the constant increment, which is 500 Ghana cedis, using the formula that we just got from the steps, right? Right. So another thing, please, when you are punching this in your calculator, make sure you do it right, because it can give you a different value. You punch this using a fraction, open the first bracket, you have the fraction sign, open another bracket for this. So you punch everything here. Don't leave anything out. If you do that, if you don't do that, you get a different value, right? So we know the formula, we've done that. So we're looking for the present value of that constant increment. So it is increasing by 5. That's the key. So 500 over interest rate squared plus 1 plus the interest rate raised to the power 10, that is 10 years, multiplying 1 plus 0.05 raised to the power 10 minus 10, which is the number of years times the interest minus 1, which is a constant. Also, this value here, which is 15,826.02, represents the present value of that constant increment. It is increasing by 500. That is what you get at the end of the 10 years. Also, when you're punching this on your calculator, please take note of the brackets and the signs. Right? Make sure you don't leave anything out. You don't leave anything out, sorry. If you do that, you are going to get a different value or a wrong answer. Right. So the present value total or the net present value is equal to the present value of the uniform cash flow and the present value of that of the constant increment. So you add the two to get the present value total, which is 38,991, right? 0.22 or so, right? Okay, so that is how we go about the arithmetic gradient cash flow, right? Find the present value of that uniform amount, that will give you this. You find the present value of that constant increment, that is your K, using this formula, and that will give you this. To get the total present value, it is the summation of the present value of the uniform cash flow plus the present value of the constant increment, right? So if it is decreasing, it would have been minus here. Okay. On our next slide, we'll look at another example. The income from Precious Metal Mining Corporation has been decreasing uniformly for 4 years. Right. So if income in year 1 is 300,000 Ghana cedis and it's decreased by 30,000 Ghana cedis per year to year 4, what is the present worth of income stream at 5% interest per year? So here you can see that the income for year 1 is 30,000. Sorry, this should have been an outflow. Just say it is increasing by, the inflow is 300,000, but it is decreasing by 30,000 every year. So here it is decreasing. So we subtract. So what do? Find the present value of that uniform amount, i.e. the 300,000 for the 4 years. That is 300,000 over the interest rate 1 plus the interest rate raised to the power 4 minus 1 all over 1 plus the interest rate raised to the power 4. And that will give you an amount of, we have, I think, it is going to give us an amount of, 1,063,785.15, right? That is the present value of the uniform cash flow, 300,000. You find the present value of that constant decrement, or the decrease, which is 30,000. So 30,000 here, K, interest squared 1 plus the interest raised to the power 4 times this will also give you an amount of 153,084.34. So here the total is the present value of the uniform amount here minus the decrease or the constant decrease, which is 30,000. That will give you this amount. So subtracting that will give you 910,700.79. Sorry. Okay. And that is for the arithmetic as well. So when you are receiving an income and it's also decreasing by a certain fixed sum, then you just subtract the present value of that constant increment from the present value of the uniform amount, and that will give you the total. Right. The final aspect has to do with the third type of cash flow, which is called the geometric gradient cash flow. Here, you are receiving an amount, but that amount is increasing by a percentage. So this is similar to that of arithmetic gradient cash flow, except that payment at period T is always increased by G%. That's the growth rate. So it's increased. You are receiving a uniform amount, but it's increasing by a percentage of the payment at period T minus 1. That is, the payment at period T is 1 plus the growth rate percent, that's the growth rate, multiplying the payment at period T minus 1. The total present value of such cash flows, which is the geometric gradient cash flow, is given as these two formulas here. Remember, they will give you you are given an interest rate, but that amount you are receiving is increasing by a certain percentage, which is the growth rate. So if the growth rate or the percentage increment is equal to your interest rate, you use this formula here to find the present value. Again, if the growth rate or the percentage at which the amount is growing is equal to the interest rate or your R, then the present value total is that annuity or the equal amount bracket of 1 plus the amount or the annuity bracket open, or you open a parenthesis, 1 minus bracket open 1 plus G over 1 plus I raised to the power n all over I minus G, where G here is the growth rate or the rate at which the amount is increasing, and then I is the interest rate. And then when the growth rate is equal to your interest rate too, you use the formula here to find the present value total. It is simply the amount or the annuity, parenthesis, the number of years over 1 plus the interest. That is what the geometric is also saying. So, right, we have the geometric gradient cash flow, a practical example on that. So the academic fees of UG is set to increase by 10% per year. 10% per year, that's the interest rate for the next 4 years. You are a first year student and the fee is 1,000 Ghana cedis this year. Your guardian will be traveling for a while and would like to deposit an amount today into a fund that will be sufficient to pay the total of your tuition for the 4 years. How much should your guardian deposit today in the fund? If it pays an interest rate of A, 10%, and B, 5%. Looking at the question over here, your ward wants to deposit, so that is for the 4 years, an annuity on an equal amount of what? 1,000 throughout the 4 years. And it is increased by, so this is the growth rate. So G is 10%, right? N is 4. So here A is what? 1,000. G, which is the growth rate, is 10%. Your interest rate, looking at the first option A here, is 10%. And you have your number of years to be 4. Looking at these two rates here, i.e. the growth rate and the interest rate, the growth rate is equal to the interest rate. So we use the first formula, which is saying that it is the annual or the equal payment into brackets N over 1 plus I. So the equal amount or the annuity is A, N is 4, 1 plus interest, which is 10%, 0.1. That will give you 3,960.40 as the amount that your guardian should be depositing in the fund at that interest rate. B here is saying that when the interest rate is equal to 5%, we already know that the growth rate is 10%, interest is now 5. So growth rate is not equal to interest rate for the second option. So here we use the second formula. A is still 1,000, G is 10%, I is now 5% based on the option here, and which is the number of years is 4. We use the second formula here because growth rate is not equal to interest rate. 5% is not equal to 10% or vice versa. So the total is that the amount, which is the annuity bracket of 1 minus 1 plus 0.1 over, because the first one is growth rate, which is 10%, 0.1. 1 plus interest, which is 0.04 raised to the power 4 over your interest rate, which is 5% minus the growth rate. I'll take it again. It is your equal amount or the annuity, parenthesis, for the numerator, it is 1 minus bracket open 1 plus 0.1 over 1 plus 0.05 brackets closed, all raised to the power 4. Over the numerator is 0.05 minus 0.1, and that should give you 40,090.37 as the amount of money the guardian should be depositing in the fund that pays an interest of 5%. The guardian will be depositing 4,090.37 for the 4 years. Okay. So make sure that this formula over here too, when you are using a calculator, please you'll be mindful of the brackets, and then how you punch it on the calculator, the signs and the fractions as well, right? So you can take this, find the value of this, the total value for, you can punch the numerator, get the answer, divide it by 0.05 minus 0.1, you multiply it by 1,000, and that should give you the answer. So you find this, write it somewhere, you find this, you also put it somewhere. The value you had here divided by what you have here, then you multiply it by 1,000, that should give you this answer over here. Right. Considering the last one, we will look at the final aspect of financial maths, which has to do with a uniform cash flow in perpetuity. Uniform cash flow in perpetuity here is a series of equal payments, ideally received forever. So the present value you are seeing here, the formula is simple. It is just the annual amount, or that uniform amount you are receiving over the interest. Because it's forever, it's received forever. So it's a series of equal payments received forever. The present value formula is simple because there is no end, right? So it's like you're receiving 20,000 Ghana cedis forever at an interest rate of 5%. It is just the amount you are receiving, the 20,000 divided by 5%. So let's take a practical example here. Say you are receiving $2,000 from your dad every year forever, right? And the interest is 5%. So the present amount here is what? The $2,000 over 0.05, which is the interest, and that should give you $40,000. It means that the forever payments that you are receiving, that is the 2,000 forever, are worth, or is worth $40,000 today, right? It's worth $40,000 today. That is what the perpetuity is trying to say. We are done with this session. Thank you so much for tuning in. I truly appreciate your time and your support. If you enjoyed this session, I'll kindly urge you to like, comment, and subscribe. And then if you have any question, you put it in the chat box or the comments section. I look forward to seeing you in our next session. We'll be looking at other topics as well to be able to understand the concept of business maths. I wish you all the best, and it's a goodbye for now.